The purpose of this video is to find and classify extrema points. Now, extrema points are simply a fancy way of saying min or max points. So we got minimum or maximum points. So as you can see on this quick little sketch here, this is an extrema point, that is at a maximum, and that's at a minimum. We would call those both extrema points, all right? Now, something that's true about extrema points is if you draw a tangent line at an extrema point, whether it be at a minimum or a maximum, notice that the tangent line is horizontal, and the slope of that horizontal line would be 0. So the way you're going to find extrema points is by taking the derivative, which in this case we just do the power rule, and you take the derivative and you set it equal to 0. And when you set it equal to 0 and you factor from here to here, and then you solve for x, what you're doing is you're finding out the places where the slope or the derivative or the gradient, remember all three of those words are the same thing, you're finding out where the slope is 0. So in other words, this function here, and I'm assuming you already know how to do the power rule, so I'm moving very quickly here, that this little ticky mark here, and the very second step is the derivative of the original function. So I take the derivative, set it equal to 0. The greatest common factor out of these two pieces is an x. Factor out an x, and I'm left with x times 5 minus x squared. So I actually get three different solutions. So x equals 0 is one of them. And if I set 5 minus x equal to 0, and I solve for x, and I square root both sides, I end up getting plus or minus root 5. So I actually have three extrema points. So I have found them. That's just finding them. Now I need to classify, which means I need to determine, is this point a maximum or a minimum? Is this point down here a maximum or a minimum? So now I'm going to classify them. The way I classify them is with a first derivative test. Okay? So there are three extrema points. I have to do three different tests. In the upper right-hand corner, this is test number 1. I'm testing 0. Okay? So this point, 0 comma something, is a minimum or a max. So TTL means to the left. I'm going to pick a number to the left of 0, and a number to the left of 0 would be -1. A number to the right of 0 would be +1. Now, what the first derivative test tells me is that if I plug this number into the derivative, I'm going to plug it into this guy here. This is my yellow thing now. If I plug a -1 in the place of x here and the place of x here, I'm going to get a -1 times 5 minus 1, which is 4. 4 times -1 will result in a negative result. I don't care what the number is, I just want to know what will that number be. Okay? So now I'm going to test a number to the right. If I plug 1 in here and I plug 1 in here, I get 1 times 4, which is a positive result. Now, going back to Algebra 1 here, I want you all to visualize a negative slope. What does that look like? Doesn't that look like downhill, right? So a negative slope means going down. A positive slope means going up. So to the left, the slope is negative. To the right, the slope is positive. That means that this point is forming a valley. So that means it's a min. Okay? So x equals 0 is a minimum point because the slope on the left is going downhill and the slope on the right is going uphill. Remember, derivative is just a synonym for slope. Okay? So I have classified that 0 is a minimum. Now I'm going to test square root of 5. Now square root of 5 as a decimal is about 2.3. So a number to the left of 2.3 is 2. A number, the next whole number bigger than 2.3 would be 3. So I'm going to do the same thing. I'm going to test -2. I'm going to put -2. It's getting real messy here. I'm going to put +2 into the place of x here. So that would give me 2 times 2 squared is 4. 5 minus 4 is a +1. 2 times 1 is a positive number. Now I'm going to plug in 3. I'm going to plug +3 in the place of x here. Place of x here. 3 times 5 minus 9 would be negative. Positive times a negative is a negative result. Okay, now let's visualize the slope again. To the left, the slope is positive. That's going uphill. To the right, the slope is negative, so that means it's going downhill. Notice it's forming a peak or a maximum point. Okay? So this ordered pair, square root of 5, is a maximum point. 0 is a minimum point. I am categorizing them, or I'm classifying the points after I have found them. Now I have one more test to do at negative square root of 5. So I'm going to test negative square root of 5. Now this as a decimal again is negative 2.3. So a number to the left of negative 2.3 would be negative 3. A number to the right of negative 2.3 is negative 2. Okay, just visualize this on a number line. Here is 0. Here's negative 1. Here's negative 2. Here's negative 3. And 2.3 is in between negative 3 and negative 2. So to the left of that would actually be negative 3, and to the right would be a negative 2. So negative 2 is bigger than negative 2.3 because it's closer to 0. So now we're going to do the first derivative test again. So we're going to put negative 3 into the derivative. If we put a negative 3 here, negative 3 here, we're going to get a negative 3. Negative 3 squared is 9. 5 minus 9 is a negative. So we're going to get a negative times a negative, which will result in a positive value. Getting kind of messy here. So now if I take negative 2 and I plug it into the derivative, remember this is the first derivative test. So you put it in the into the derivative. Okay, 5 minus 4. We end up getting negative times a positive, which results in a negative. So let's do the visualization of the Algebra 1 slope here. To the left is positive. A positive slope looks like that. And to the left, it's negative. A negative slope looks like that, which must mean that this point must be a maximum. Okay, so I have found 3 extrema points, and I've classified 3 extrema points. Now I'm going to put this information on a graph and sketch it really, really quick and state the intervals of increasing and decreasing. Okay? So notice I left here this ordered pair, the y value blank. All right? So now that I want to know a y value, I'm just going to plug it into the original function. I plugged these numbers into the derivative because I wanted to know what the slope is. But now I want to know what the point is on the graph. So now I'm going to take 0 and I'm going to plug it into the original function right here. All of those pieces go to 0, leaving me with a constant of 3. So 0, 3 is a point on the graph. So if I want the y value, it goes into the original. So I plug in 0 in for x and I get 3. Now I'm going to find the ordered pair for square root of 5, which is a little bit messier. And I showed my work on the next slide over here. So if I want to know what the maximum point is, or if I want to know what the y value is at square root of 5, square root of 5 is what I just found in the very first slide, okay? I've already classified it. I know that it's a max, but I did not know what the y value is. So now if I plug in square root of 5 here and here, I end up getting 9.25, okay? And I already know that it's a maximum point because I classified it here. I just want to know what the y value is. It's 9.25. Okay, so that means on my graph, here's square root of 5 here. All right. And just so you guys know, if you put in negative square root of 5, which is the other, this is the other extrema point, or the other maximum, it's also going to be positive 9.25, because if I put a negative in here, if I put a negative here, raised to an even power, all these numbers are going to be exactly the same. Okay? So this is also 9.25 for the y value. Okay? So now what I'm going to do is I'm going to put these 3 points on the graph. So we have a maximum here at square root of 5, a maximum here at negative square root of 5, and we have a minimum here at 3. And it just kind of connects there like that. Okay? And the graph's going to go down. I know it can't go back up again because there's only 3 extrema points. It's got 2 peaks and a valley, like the golden arches here. Now I'm going to state the intervals of increasing. This goes all the way back to chapter 2 in this class. So we're going to scan the graph from left to right. So starting from the left, this graph starts out going up. It's increasing from negative infinity. Once it hits the square root of negative 5, it stops. So it goes up to here, it stops, and then it starts to go downhill from negative root 5 to 0. It's decreasing from negative root 5 to 0. And then it starts to go uphill again, uphill from 0 to positive square root of 5. And then it starts to go downhill again from root 5. And it doesn't stop decreasing, goes forever to the right. So if you scan the graph from left to right, we start out at negative infinity. It hits negative root 5 right here. Then it starts to go downhill from negative root 5 to 0, which is here. Then it goes uphill again from 0 to root 5, and then it goes downhill forever. Okay, now notice on the intervals of increasing, decreasing, I'm only using x values. The fact that these points go up to 9.25 on the y-axis, that's just to help me sketch the graph. Okay, that tells me that this graph goes to the height of 9.25, so I can kind of state the range. The range is anything less than 9.25. But as far as intervals of increasing, decreasing, they're not. The y values are not used.